All right. So on number 3, what do those 3 numbers have in common? 7. Do all 3 terms have m? Take the smallest exponent. Now, I'm going to put 3 reduced terms back. 14 divided by 7 is 2. Subtract the exponent. 6 minus 2 is 4. 35 divided by 7 is 5. Make sure you keep that negative. Subtract the exponent. I get m to the first. Negative 7 divided by negative 7 is negative 1. You can't just drop that last one. A number divided by itself is a 1. And when you subtract the exponents, you get 0, so the m stays away. So before I do anything else, I check 2, 5, and 1. They don't have anything in common. So that would be my final factored version. Now, sometimes you don't have any numbers in common. 3, 5, and 8 have absolutely nothing in common. Do y'all agree? So, do all 3 terms have an a? What's the smallest exponent? 1. Do they all have a b?
Yes.
Smallest exponent is a 1. So 3, subtract the exponent, the a cancels, the b doesn't. The negative 5 stays, subtract the exponents on a's. When you subtract the b exponents, it becomes a 0. And then I end up with just 8 on the end, because when I subtract those exponents, I get 0. So the a and the b will drop out of that last term. 3, 5, and 8 have nothing in common, and they don't have any common variables left. So that would be the undistributed factor version of that problem. Okay? Now, when it comes to factoring, you always look for a greatest common factor first. I don't care if you have 3 terms, 4 terms, 5 terms. Does not matter. Always take out the greatest common factor first, because what is left behind has smaller values and smaller variables in it, and it's always easier to work with the smaller numbers. Okay? Cell phones go away. This is my time. Gonna have your cell phones out at lunch. All right, so when we are factoring trinomials where our a value is 1, if you look at all of these until you get down to the last row, there is a 1 in front of every squared term. Do y'all agree? Okay. Now, I want to go back over and just kind of review the sign rules with you, because it does have a sign rule. So if you have x squared plus bx plus c equals to 0, this is going to factor into 2 parentheses, not equal 0. I'm sorry, we're not ready for that yet. This is going to factor into 2 binomials, so we are unfoiling this problem. Do you see any negatives up here? Then your factors cannot have any negatives. Okay? Now, that's the first sign rule. No negatives, no negatives. The second and the third sign rule actually will involve negatives. So the second rule says, well, what if I have a or x squared minus bx plus c? I now have a negative involved. Okay? What I do is I look at the c value. If the c value is positive, I have to use 2 negative signs. Okay? Because a negative times a negative will give us a positive. All right? So if c is positive, then you use 2 negative signs in that problem. Okay? Now, the third scenario, your bx value can be positive or negative. It does not matter which one. It's not going to be both. It's going to be one or the other. But my c value is negative. When your c value is negative, you're going to have 1 plus and 1 minus factor every single time. So before I do anything else, I make sure my problem is written in format, x squared plus bx plus c, and then I decide from the get-go, Should I have plus, plus, minus, minus, or one of each? Okay. All right. So in my first problem, it is in order x squared plus bx plus c. I see no negatives, so my final answer is going to be a plus plus. Now, I'm going to take the first number and I'm going to split that exponent in half. What's half of 2? What's half of 2? 1. So x to the first, x to the first. If that were x to the fourth, split 4, it'd be x squared and x squared. You can only split even numbers evenly, okay? If that were x to the third, we'd have to do something totally different to it. So we want even exponents on that first number. Now, we already said there are no negatives. So what we're going to do is I'm going to look at 45. I want factors of 45 that when I add them together produce 14. Okay, 9 and 5. 9 times 5 gives me 45, and 9 plus 5 gives me 14. It does not matter if you write it with the 9 first and the 5 second, or if you write it as x plus 5, x plus 9, as long as you have the 9 and the 5. Now, if you want to check it, you can FOIL it back out, because what we just did is we unfoiled that trinomial. And so if you wanted to multiply it back out, you can multiply it back out, and it should end up being x squared plus 14x plus 45. Okay? In our second problem, number 6, I know I said our second problem, but it's the second one in this group of factoring. I'm in order, x squared plus bx plus c, even though it's a w, it's still the same thing. Based on my sign rule, I see one negative. Since this number is positive, I have to use 2 negatives, because a negative times a negative will produce that positive 26. Okay? Next thing I'm going to do, take the front number, split it. So that's w and w. So now I need factors of 26 that will produce negative 15. What that means is both of my factors of 26 end up being negative. Okay, so I know 13 times 2 gives me 26, but it doesn't add up to negative 15. But negative 13 times negative 2 is still positive 26, and negative 13 plus negative 2 equals negative 15. So it does not matter where you put the 13 or the 2, both of them should be negative. Okay? And this would be your final answer. If you have the w minus 2 parentheses in front of your w minus 13, that's fine. All right? For the next two, 7 and 8, the position of your numbers absolutely matter because the last number is negative. When you have your C value is negative, you will always have 1 plus 1 minus. Even over here, our C value is negative, so we'll have 1 plus 1 minus. Now, it's a habit of mine, I always put the plus sign first. But if you want to put minus plus and minus plus, go for it. You need one of each sign. So in the first one, I'm going to split that C. Now this time, I need factors of negative 48 that when I add them together, give me a positive 2. The only way you can get a negative 48 is to multiply a negative times a positive, correct? So now, instead of adding the two numbers, I technically want to kind of mentally subtract them to get a 2. Okay, so I think 6 and 8. Do you agree the difference between 6 and 8, if you were to subtract these numbers, are going to be 2 or negative 2? depending on how you do it. Does 6 times 8 equal 48? Okay, so now we have a choice. Is it going to be negative 6 times positive 8, or is it going to be 6 times negative 8? Both of those multiply up to negative 48, but which pair adds up to positive 2? The negative 6 and the 8. So I'm going to put the 6 with the negative and the 8 with the positive. Now, another trick that you can think of, since this number has to be positive, the biggest factor has to be positive. Whatever this number is, the bigger factor needs that sign, the smaller factor gets the other sign. So I'll talk about that in this next problem. So we already said, since this value is negative, we use one of each. We're going to split our n. I need factors of negative 72 that when I add them together give me a negative 1n. 9 and 8. Okay, now here's how you decide which one of those numbers should be negative. Since the outcome that I want is negative, the bigger factor gets that sign. I want a negative number, so I'm going to put the negative with the 9 and leave the 8 positive. Over here, if you notice, we wanted a positive outcome and 8 stayed positive. It was bigger. So that's how you can kind of determine which one of those numbers should be negative and which one should be positive. So we're going to stick the 8 there, the 9 there, and we have it unfactored. Okay, the next two, we're going to do both of these the same exact way. The outcome is special when you do this. When I look at this problem, I see no negatives, so I know I should have a plus plus set of factors. I want factors of 36 that will add up to 12. I don't have to worry about a single negative anywhere. There's no negative in my problem. 6 and 6. 6 times 6 is 36. 6 plus 6 is 12. So split your A, and do pay attention to that in Math Excel. They don't always use X squared problems. Every now and then, like up here, we've used X, W, N, C, and now we're to A. Pay attention to that because we get into that rut and we always put X. I catch myself wanting to do that too instead of the actual variable in the problem. And although you have the numbers right, you have a 6 and a 6. If you type in X plus 6 and X plus 6, it's going to mark it wrong because you used the wrong variable. Does that make sense? Now, what makes it special is your factors ended up being exactly the same. So the only other thing that you could do is write A plus 6, not B, A plus 6 squared, since there are two of them. And you can only do that when the factors are exactly the same. All right. What are my signs for number 10? Both negative. Since my A value is positive, a negative times a negative produces a positive. I'm going to split that in. I need factors of 1 that add up to negative 2. Or there's only one factor of 1. 1 times 1, correct? Okay. 1 times 1. What's 1 plus 1? 2. Problem is, both of those numbers need to be negative. Negative times negative is positive 1. Negative 1 plus negative 1 is negative 2. So here again, since both of our factors are the same, if you want to write it as n minus 1 squared, you can do that. Now, number 11 and 12, that they actually incorporate the greatest common factor with the trinomial factoring. So they're combining the two methods of factoring. We haven't run across one of these yet. These are the first two. If you look across this problem, do you agree every number is divisible by 2? Okay, so I'm going to take out a greatest common factor and I'm going to reduce the terms when I put it back. 2 divided by 2 is 1, so that's just a k squared. Negative 16 divided by 2 is negative 8k, and negative 40 divided by 2 is negative 20. Okay, now you have been able to factor it. You have taken out a greatest common factor. The next step is, can I actually go further? Do I stop here, or can I actually take it further? Sometimes that's as far as you can go. Okay, notice that I pulled that 2 down. It comes along, it's part of our answer. Now, looking at my signs, I know I need one positive, one negative. I'm going to split my k, and then I'm going to hope that I can find factors of negative 20 that add up to negative 8. 5 and 4 adds up to 9. Okay, 10 and 2. Which one needs to be negative to produce the negative 8? The bigger number. So negative 10 times 2 is negative 20, but negative 10 plus 2 gives you negative 8. So I'm going to put the 2 with the positive and the 10 with the negative. So I was able to take that further than just a greatest common factor. So that incorporated greatest common factor and trinomial factoring. All right. The last one in this section, what do all three of those numbers have in common? A 5. So I'm going to put 3 reduced terms back. 5 divided by 5 is 1. 25 divided by 5, that gives me that negative 5 in the middle. 30 divided by 5 is 6. Now, one of two things happens. That's as far as I can go, or I am able to break it down. I have to try to break it down. What are the signs going to be? Both negative. So I'm going to split my z. Now I need factors of positive 6 that when I add them together give me negative 5. Six is very tricky because if you think about it, you can add 2 and 3 and get 5, but if you take 6 and subtract 1, you also get 5. Which pair is it? Is it the 2 and the 3 that's going to add up to the 5, or are you subtracting to get the 5? Which one are you doing? I'm sorry? So 2 times 3 gives me 6. 2 plus 3 gives me 5. But since that's positive, we're going to make them both negative, and that works out. Negative times negative is positive 6, and then when you add that, does not matter which one you put the 2 or the 3 in because they are both negative. That would be your final answer, greatest common factor included. Okay? Now, the tricky part for me is the next section, because you've all come from different Algebra 1 teachers, and I don't know how your Algebra 1 teachers have taught you how to factor these types of trinomials, okay? So these trinomials, if you notice, now have an a value in front. There's a 2. I can't factor the 2 out because 15 and 2 don't have anything in common. There's no greatest common factor. Over here, 5, 22, 48. All three of those numbers are not divisible by 5, so I can't do what we did in the last two problems. So when there is an a value, we have to approach it a little bit differently. The only thing that is consistent is the sign rule. My final answer should have what two signs? Negative. That's the only thing I know right now. When I see this 2, the first thing I should think, do I have a greatest common factor? No, I do not. Okay, so what we are going to do is we are going to create a trinomial that looks like this with a 1. Okay, I don't know if this is how your math teachers taught you, but this is how we're going to do it. If you remember how to factor it and you can do it your way and you don't want to do it my way, do it your way. I'm not going to tell you that you have to learn my method for factoring. So if you can factor this, you go right ahead and factor it your way. All right. So what we're going to do is we're going to multiply the A and the C value together. So the first number with the last number, make sure everything is in order. X squared plus BX plus C. So what's 2 times 18? 36. So I'm going to rewrite this problem as x squared minus 15x plus 36. Y'all with me? So I took the 2, I took it back here, and I multiplied it. All right. Now, that presents a problem like we were just doing. What are factors of 36 that will add up to 15? Three and 12. All right. So I'm going to do x minus 3, x minus 12, because we already said that we were going to use minus minus. We already established that from the get-go. Do y'all agree? Now, the problem is when I go to say x times x, I don't get 2x squared. I get 1x squared. Do y'all agree? So when we multiplied the AC together, we're now going to have to divide the A back out. So we multiply it and then we divide it, and that goes kind of full circle. So what I'm going to do is I am going to take the two numbers that I see, the 3 and the 12, and divide them by 2. They either reduce or divide out or neither. Hey, what's going on? Yeah, I know. Yep, I'll send her. Bye. All right. I'm going to butcher your name. Pronounce your first name for me. Kanishka. You need to go down to the library. Okay. You might want to take your stuff with you. All right. All right. So does 3 over 2 reduce or divide out at all? Okay. So what we're going to do, if it doesn't reduce or divide out, we're going to move that number, the denominator, to the front. So that's going to become a 2x minus 3. Now, in the second group, does 12 over 2 reduce in any way, shape, or form? Yes, it reduces all the way down to 6. Y'all agree? Here are my factors. Notice we do have 2 negatives. If I were to FOIL this out, look at the first term. 2x times x gives me 2x squared. That's the first term. When I go to do the outside numbers, that gives me the negative 12. The inside numbers give me the negative 3. Those are the factors that you told me were going to give me that 15 in the middle, remember? And then when I multiply negative 3 and negative 6, I get that positive 18 at the end. Okay? Does that make sense? All right, we will pick up after lunch right there. During lunchtime, y'all don't have to ask. You can just go. All right, 16. First of all, when I look at that, I see a -2 back here, so I know it's going to be a plus and a minus. I got my signs. Now, I cannot take out a greatest common factor. 5 kind of messes that up. So I'm going to multiply 2 or 12 and -2. That gives me -24. So I need factors of -24 that are going to add up to 5. If it's negative, one of the numbers has to be negative. 8 and 3. 8 times 3 is 24. And then which number would be positive? The positive, yeah. So if I took +8 and -3, that gives me 5. Okay, so we're going to rewrite that as x squared plus 5x minus 24. Then we're going to factor that into the x plus 8 and x minus 3. When you take those numbers and multiply them, you get -24. When you add them, you get +5. Then I have to go back and grab my 12. And I have to divide both of those numbers by 12. Now, they do not divide out evenly, but they do reduce. Cell phones go away. Lunch is over. So, what does 8 over 12 reduce to? Two-thirds. What does 3 over 12 reduce to? 1/4. Okay, so that 3 is going to go up in front of that x, and that denominator 4 will go up in front of that x. So I'm going to have 3x with a +2. Move that denominator up in front. Second parentheses, that would be a 4x minus 1. Now, when you go to check this, here I get my 12x squared when I FOIL it. This is the -3x and the +8 that you told me would produce that +5. And then when I do the last two terms, I do get -2 at the end. So when I FOIL it all back out, it does go back to the original problem. So these are your final factors. All right, let's do one more of those, and then we're going to move down to the bottom and do some difference of squares. You only have 5 to choose from. Don't all of you yell at me at once. You will scare me. I'm old. I scare easy. 17. All right. Do I have a greatest common factor? Nope. My signs are going to be plus minus because that last number is negative. What do you get when you multiply 6 and -21? -126. So we're going to rewrite the problem as y squared minus 5y minus 126. Okay, we have already said 1 plus and 1 minus. Now I need to come up with the factors of 126, -126, that when I add them give me that -5. One factor has to be positive, the other factor has to be negative. Nine times 14, perfect. 9 times 14 gives you 126. Which one would have to be positive to produce the -5? Correct. So when you multiply them, you get -126. When you add them, you get the -5. So the 9 goes with the plus, the 14 goes with the negative. What's the next step? Divide by 6. Now, neither one of these divide out evenly like some of the other ones do, but we can reduce them. So this would be 3 over 2. Both numbers will reduce by 3. In the second parentheses, both numbers reduce by 2. So that would be 7 over 3. And then, since we can't reduce it or divide out any further, this 2 goes up in front. So I get 2y plus 3. This 3 goes up in front and gives me 3y minus 7. You can always check it, FOIL it back out, and make sure that it works. All right, everybody okay with that? All right, the last group of factoring that we're going to talk about, and then we're going to go on to the next page and do a little bit of the solve the equations by factoring, are differences of squares. Now, difference means to subtract. It has to be a subtraction problem or you cannot do it. Okay, so what we're going to do is we're going to do a squared minus b squared. Binomial. Difference of squares is a binomial. Okay, what you look for, even exponents. It's a binomial. You need even exponents. We already said it had to be a subtraction problem. It cannot be an addition problem. And then you look for perfect square numbers. Any number that's not an exponent has to be a perfect square. 1 is a perfect square. 1 times 1 is 1. 4 is a perfect square. 2 times 2. 9 is a perfect square number. 3 times 3. You're looking for those types of numbers. Those perfect square numbers. 7 times 7 is 49. Anything that's a perfect square, that's what you look for. Exponents have to be even, perfect square, subtraction. So the way this factors is you will get a plus b and a minus b every time. 1 plus 1 minus. Okay, so do I have binomial? 2 terms. Are you subtracting those 2 terms? Okay, is the exponent even? Is the number a perfect square? Okay, so what I'm going to do is I'm going to put 1 plus 1 minus. I'm going to break that up to x and x just like we did before. What number do you square to get 4? 2. 2 times 2. That's it. Same thing. Binomial, yes. Subtraction, yes. Even exponent, perfect number. So I'm going to write y plus 9 and y minus 9. Split up the y, break up the 81 into its perfect factors, 9 times 9. Now, is it okay if they have 2 numbers as long as they're perfect? Yes. 9 is perfect, 25 is perfect. 2 terms, binomial, subtraction, even exponent, perfect numbers. Be careful here because that's a 4, not a 2. So we're going to break this down. This breaks up to 3x and 3x. Do you agree? 3x times 3x takes me right back to 9x squared. 1 plus, 1 minus. When you break up the 25, you get 5 times 5, but you have to half the 4. So that's going to be 5y squared and 5y squared. That's why the exponents have to be even in order for you to do that. All right. This problem, binomial, even exponents, everything checks. This time I'm going to break up and have my 2 variables together because they are collected as one term. How do I break up the 49? 7 and 7. And that would be your factor. If you want to put the -7 first and the +7 last, it doesn't matter as long as you have one of each. All right. The last one I want to show you is actually number 26. And in number 26, we have a GCF. We have a GCF, and then it will turn into a difference of squares. So this is when they combine two different sets of factoring. So you have to pay attention. Do you agree that both terms have a 2 in common? Okay. Do they both have A's? Smallest exponent would be a 2. They both have a B, so I'm going to take that B. 2 divided by 2 is 1. When I subtract the exponents, I just get a 1. That's all I get. Do y'all agree? 32, or -32, I should say, divided by 2 is -16. Subtract the exponent, you get a square, and what happens to the b? It goes away, because when you subtract the exponent, 1 minus 1 is 0, so it drops out. Now, here's my GCF. That's my greatest common factor. This just so happens to be a difference of squares. Two terms, even exponent, subtraction, and perfect numbers. A lot of times people forget that 1 is a perfect number. So I'm going to have my 2a squared b. I'm going to have my 2 parentheses. Since 1 is first, I'm going to split the 1. 1 times 1. Plus, minus, and then how would I break up that 16a squared? 4a and 4a. So that is where they combine both greatest common factor and difference of squares. Any questions about that one? All right, now we're going to do all this again when it comes to solving quadratics by factoring. They give you steps, flat out steps. It says move all terms to one side and set the problem equal to 0. So we're going to move everything to one side. Then you're going to factor. Everything on this page will factor. Okay? Then once you get it factored, this is the next step. You're going to set each factor equal to 0 and solve the little bitty equations. And then you will write your answer in this format. X equals with the braces. Parentheses means an ordered pair. This is a solution set. Okay? So, first step. Is the problem set equal to 0 for me already? Okay? Now, when I look at this, I have to factor. I have 2 terms. Do you have a common factor? I have an x in common. When I take the x out, what 2 reduced terms go back? X plus 9. That is correct. Now, this is not a difference of squares because it's an addition problem, so don't even have to worry. It doesn't even have a square like an x square anymore. So don't have to worry about trying to break that down. A lot of times people see that 9 and go, oh, I can break it down further because 9 is perfect, but you can't. It doesn't meet the requirements for it to be a difference of squares. So you have 2 factors. This is a factor, greatest common factor, and you have a binomial factor. So the third step says set each factor equal to 0. So I'm going to take x and set it equal to 0. And then I'm going to take x plus 9, the other factor, and set it equal to 0. Then at that point, you have 2 small equations that you have to solve. Nothing's going on here, but I am going to subtract my 9. So my answer with braces would be 0 and -9. If you want to put the -9 first and the 0 second, that's fine, but those are your answers. All right. Another binomial. Do you have a greatest common factor? And not just the 4, but there's a variable, 4x. So when I write this, 4 divided by 4 is 1. Subtract the exponent. Negative 8 divided by 4, negative 2. When you subtract the exponent, it kind of drops out. The variable drops out. So you have 2 factors. You have the 4x, which is the greatest common factor. So we're going to set that equal to 0. And then you have the x minus 2 factor that we will also set equal to 0. When you divide both sides by 4 in the first one, you get 0. Remember, it is okay to have 0 in the top. Okay? When we add 2, we get x equals to 2. So your solution set will be 0 and 2. Now, the next 2 are also binomials. And then you notice 5 and 6 starts getting into trinomials. Now, do you have a greatest common factor? Like we did in number 1 or number 2? No. Is it a difference of squares? That's the only other option. If you have a binomial, you have 2 options. Number 1, greatest common factor, which we did up here. Number 2, difference of squares. If it's not one of those 2, you cannot factor it. Okay? I can factor that to x plus 2 and x minus 2. That's a difference of squares. I take each factor, set them equal to 0, and I solve it. I get negative 2 from the first equation and positive 2 from the second equation. So my solution set is negative 2 and 2. Any questions about that? All right, difference of squares. How would you factor that problem? There is no greatest common factor, so I can't do this part. It is a difference of squares. How would you factor it? Say that again. How would you break up the 9x squared? What times itself gives you 9? So 3x and 3x. Always 1 plus 1 minus. How do you break up the 25? The 5s. So I get 3x plus 5 equals to 0. And I get 3x minus 5 equals to 0. So first equation from the first factor, second equation from the second factor. Subtract the 5, divide by 3. On the second equation, I'm going to add 5, and then I'm going to divide by 3. Now, every time you factor a difference of squares, notice that you get one of each answer. Same number, positive and a negative. So here, same thing. I got a negative 5 over 3, and I got a positive 5 over 3. Okay, so those are some binomial examples. You do not do this part unless you see that equal 0. If you don't see the equal 0, you're just factoring. All right, last 2 problems that we're going to do today are number 5 and number 7. Or let me rephrase that, the last 2 problems I'm going to do today, number 5 and number 7. So, number 5, is it set to 0? It's not a binomial, But do you have a greatest common factor? Okay. What will your signs be? Both negative. So split your x. Now, I need factors of 21 that will produce 10. Okay. 7 times 3 gives me 21. But in order for it to produce a negative 10, I have to make them both negative. That's what we said. So negative 7, negative 3. So I have factored the trinomial. The only difference is it's now an equation that I have to solve. So I'm going to take each factor, go the extra step, and I only do this when it's set to equal to 0. So x equals to 7 and x equals to 3 when you solve both of those equations. So your solution set, 7 and 3. Now, the reason I wanted to do number 7 is it's because it's one of those trinomials that does not factor. Okay, actually, I am going to do one more. I know I said this was the last one. Do you have a greatest common factor? No. So what will your signs end up being when it's all said and done? A plus and a minus. Do y'all agree with that? All right. Now, what is 3 times negative 30? Okay. So x squared minus 13x minus 90. This is what I'm trying to factor. Okay. So I had to do the AC. I need factors of negative 90 that are going to produce a negative 3. I mean, a negative 13, I'm sorry. $18 and 5. So that would be, you said 18 times 5 gives you 90. Which one would have to be negative so that I get the negative 13? The 18. So negative 18, positive 5. What do I do from this point? I'm still trying to get it factored. What do I do? Divide by 3. So this reduces all the way to x minus 6. 18 divided by 3 is exactly 6, so it goes in the minus parentheses. This one does not reduce or divide out, so that would be 3x plus 5. Remember, move that denominator up in front. Now that you have it factored, set your factors equal to 0 and solve them. So in the first equation, you will subtract 5 and you will divide by 3. In the second equation, all you have to do is add 6. So your solution set would be negative 5 over 3 and 6. Those are your two answers. All right. So on this first page, everything was set to 0, correct? All right. Pick a problem. 9 through 12. Pick problem. 12. Already. I have to set this thing equal to 0. Which means I'm going to move both of these terms to the other side. So the first thing I'm going to do is subtract the x squared from both sides. That would give me x squared minus 50 equals to negative 1. Then I'm going to add 1 to both sides. And that gives me x squared minus 49 equals to 0. So I had to do a lot of moving to get 0 on that right-hand side. Once you get it set to 0, you have to decide what type of factoring you're doing. I count my terms. If I have 2 terms, greatest common factor and or difference of squares. If I have 3 terms, I have to do the trinomial stuff. Okay? I have 2 terms. Do you have a greatest common factor? Is it a difference of squares? So what would the factors for the difference of squares be? X plus 7 and x minus 7. Once you get it factored, the factoring is the hardest part. Once you get to your factors, set your factors equal to 0. Solve the small equations that you get. And that would be your answer. Now, do you see anything else on this particular page that you would like to see? Look at all of those problems. $16? Is that what you said? Okay. All right. It's not set to 0, so I've got to move both of these. I'm going to subtract 2. So that gives me 4x squared plus 41x plus 96 equals to negative 3x. Then I'm going to add the 3x. Make sure you do add it to the correct term. So that is 4x squared plus 44x plus the 96, and it's set equal to 0 now. One, two, 3 terms. So this is trinomial. I have a number out in front. So the first thing I ask myself, is there a greatest common factor? Because if there is, then all of these numbers are going to get smaller and it's going to make it easier to factor. Can you divide all these numbers by the same thing? Okay, so that's a 4. Y'all agree? So that would be x squared plus 11x plus 24. 4 divided by 4 is 1. 44 divided by 4 is 11. 96 divided by 4 is 24. Now, what are my signs going to be? Positive. There are no negatives in this problem, so you can't have any negatives. What you're looking at now, x squared plus 11x plus 24. For some reason, my tablet just decided to freeze up. So you said 8 and 3. Now, this is a factor. 4 is a factor. But if I set 4 equal to 0, that doesn't make any sense, does it? Okay, so that gets thrown away. I basically want to take anything that has a variable in it and set that equal to 0. So I'm going to take x plus 8, set it equal to 0, x plus 3, and solve those smaller equations. X equals to negative 8 and x equals to negative 3. So my solution set would be negative 8 and negative 3. Questions about that? All right, so I want 2 questions from you. All right, I want number 8 and number 9. You do those on your own paper and turn that in. If you want to take a sheet of notebook paper and tear it in half, that's fine.